In this tutorial we're going to create and listen to a damped cosine wave. We're going to do this by means of a script rather than just typing it into the command window. So we're going to say new script, and we're going to start by saying x is equal to an array starting at 0, going in steps of pi over 20 up to 2 times pi. Then we're going to say that n is equal to the number of elements in x. Next we say that I is equal to 1, and while I is less than or equal to n, y of I is equal to exp, which is Euler's constant e raised to the power of minus x, times cos of x. Then we need to increment I, otherwise we will be in an infinite loop. And that's the end of the loop. And then finally we're going to plot x against y. When we try to run this, because we haven't saved it yet, Matlab will want us to save it. So we'll click on run, and Matlab wants us to save it. So we'll save it into a file called DampedCosine. And there's our graph of a damped cosine. Right, the first thing I want to do is to make it run for somewhat longer. So what I'm going to do is, instead of running to 2 pi, let's try running it to 20 pi. Run that, and we get... Right, what's happened here is that it's come effectively to 0 in the first cycle. So that means our damping is too great. So let's decrease the amount of damping we've got. We're going to divide the damping by 20 because I'm running up to 20 pi here. So if I run that, I get, yeah, that's more like it. So we can see how the cosine is running down to 0. Cos of 0 is 1, so it starts at 1, but by the time we've got to the first negative peak, we're already between minus 0.8 and minus 0.9. Then the cosine damps over the cycles that we've got. What I'd like to try now is listening to what that sounds like. So I'm going to add an extra line on here, which is and then run that. I don't know if you heard a slight click then, but there wasn't much of it, and the reason is that the cosine is over almost before we run it. Let's try it again. We just get a slight click there. Let's change the sampling speed. So we can play around with the variables. I'm going to introduce a variable called a, which I'm going to equal to 100 for now, and I'm going to make the x vector go from 0 to a times pi, and I'm going to divide the exponential by a instead of 20. So let's run that and see what happens. And the graph looks like that. So play the sound. So let's try running it up to, say, 500 instead of 100. And that's the end of the tutorial on damped cosines.